also the auto transcriptions in place. So again, welcome to the Edith Wheeler Memorial Library. My name is Nicole Signoli, and I am the director here at the library. We are very happy that the Friends of Edith Wheeler Memorial Library has sponsored again the Connecticut Innovation in Industry lecture series that will be presented today from Art Gottlieb. Arthur will be presenting about Pratt and Whitney. So please go ahead. Welcome, Arthur Gottlieb.
Thank you. I'm running on kind of like a 10-second lag here on my computer, so I can see myself, and if I make an expression or something or wave my arm, it happens 10 seconds later. So, and but it sounds like you can hear me okay, and you can see my photographs okay. So we'll just stick with that, and I'll have to deal with this. So I'm going to go to screen share. Okay, could everybody see Eddie Rickenbacker's airplane?
Yes.
Great.
I'm gonna go off mute, and I'm gonna.
It's okay. All right, and just let me know if all of a sudden you can't see something or something strange happens. All right, so anyway, here's Eddie Rickenbacker. Oh, welcome everybody. Good to see you. I haven't seen you in a couple of weeks. I hope you're all doing okay. I'm excited about this presentation today. It's a story about Pratt and Whitney in our Innovation and Industry series. And, you know, when I was researching this, I realized how large Pratt and Whitney actually was as far as being part of very, very large aeronautical conglomerate. So Pratt and Whitney now is actually part of Raytheon, and which is another massive conglomerate. But we're going to go back to the beginnings of where Pratt and Whitney started. And I've got a lot of photographs of historic aircraft for you, and I'm going to be talking a little bit about engines. I want to make you interested in this sort of thing without actually boring you to tears with it, which I'm certainly capable of doing. Eddie Rickenbacker, handsome fellow, isn't he, right? So he's part of, he's an American actually, who was flying for the French, and during World War I. The United States wasn't building their own aircraft. But World War I, the reason I have this picture here is because our story of Pratt and Whitney starts with World War I. World War I was a watershed of aviation technology. The reason why airplanes were being flown around over France, particularly in World War I, was for reconnaissance. You know, imagine a scenario like the Civil War, right? If General Grant or General Lee could have actually found out where their opposite forces were, I mean, it would have been pivotal in changing these battles. You just didn't have that kind of reconnaissance. You know, you had to send out spies, and you had to send out patrols, which everybody was expecting. So earlier on, people actually started using balloons because the technology was there. You had instances of people, you know, being in balloons trying to get a bird's eye view of what your opponent was up to. But in World War I, 1914 to 1918, the technology was there to have these relatively simple aircraft. And the reason why people started flying them, the armies started flying them, was to take pictures of what the other side was doing. And then because the other side didn't want to have their picture taken, they started sending up aircraft, the Germans, that had guns in them to shoot down the people who were taking pictures. And then, so the guys who wanted to take the pictures, they brought extra airplanes with the camera airplane. And the second airplane had guns also, you see. So then the airplane with the guns would fire at the airplanes from the other side with the guns so that your guy can take pictures without getting shot down. And that's actually how aerial combat started. But you need engines to make all of this work. In 1914, I mean, what kind of cars were we driving around with automotive engines? You know, you had Model Ts and things like that. I mean, it was really the first generation of the internal combustion engine. And all kinds of different designs were being used. But war has a tendency to drive forward technological progress in this regard. And so now by the end of World War I, we had utility vehicles, we had trucks, we had tanks, right? And all of them relied on some version of an internal combustion engine, right? So you had the airplane and you had the engine. The thing is that after World War I, nobody really knew what to do with airplanes. I mean, we hadn't started flying the mail anywhere before. And the idea of commercial aviation was just a crazy dream, you see. But the military application of this was obvious, right? So as you're aware, only 20 years after the end of World War I, you have World War II, right? And all of this major development of these incredible airplanes from World War II happened in the 1920s and the 1930s, immediately after World War I. And that's where the story of Pratt and Whitney comes from. Right. So there's a company called Wright Aircraft Engines, right? As this slightly blurry logo that I was able to find would indicate. And Wright Aircraft Engines was a major company of airplane engines in the 1920s, and remains so, by the way. But like many cases, you have very, very smart people who were working for some company someplace, in this case, Wright Aircraft Engines, that wasn't happy with the direction of the company. And a couple of guys get together and they say, you know what, why don't we go start our own airplane engine company? And I'll bet you we could do a better job of it. You see, you know, maybe they don't feel appreciated. Maybe they don't like the, you know, the atmosphere of the company, or they don't like the way the boss's mustache looks, or they're not getting paid enough, or maybe all of the above. You see, and that is where our story begins, with a couple of people who wanted to start their own aircraft engine company. And they left Wright Aircraft Engines. Now, simultaneously with this, there is a factory, a machine tool factory in Hartford, Connecticut, called Pratt and Whitney, right? And they made all kinds of stuff. They made sewing machines. They made parts for military apparatus during World War I. You know, you had really the whole tremendous industrial capacity of the United States engaged in mobilizing for World War I in the form of us selling armaments to especially Great Britain and France, of course, and then for ourselves once we entered the war in 1917. But here's this depiction of this Hartford factory, Pratt and Whitney shop, is from 1896. And this is a place that's been around since before the Civil War. And Pratt and Whitney was manufacturing things as part of the Union War effort against the South in the American Civil War, right? So that's how far back Pratt and Whitney goes. right? And anytime you've got a big machine shop or something and you're looking to get contracts to build things with the skills and the capability that you have. So this particular drawing, I don't think it's a photograph, is from the Vienna exhibition from 1873, where Pratt and Whitney actually had, I guess, what you would call an exhibit. And they're showing people who are interested in having manufacturing companies manufacture things for them, how sophisticated and efficient Pratt and Whitney machine tools were, you see? And there's a sign up on top, Pratt and Whitney Company, Hartford, Connecticut, manufacturers of guns and sewing machine, machinery and tools. You know, before you can actually make something like a gun or a sewing machine, or anything for that matter, you have to be able to manufacture parts to build machines, to build the parts for the gun, you see? So the process of building a machine that's going to manufacture something requires a machine shop to manufacture those parts for the machine that's going to manufacture things. And that's what Pratt and Whitney was going to do. The first job I had out of high school that I was trained in was as a machinist. And that was a very long time ago. I was, what, 17 years old. And I still have somewhere down in the basement my machine tool certification, right? As it turns out, I was kind of a lousy machinist, but that's all right. And it's another story I'll tell you someday over a couple of beers. So here's our primary person, Frederick Rentschler. Now, he was at Wright Aircraft Engine, and he was the primary person that's like, you know what? I've got one foot out the door because I think I can do everything we do here better. And as long as I'm going to put all that effort into it, why don't I do it for myself? You see, he wanted to own his own company, right? He wanted to start a new company. So here he is in 1929, Frederick Rentschler. And he grabs his buddy, who is a brilliant aeronautical engineer, George Meade. George Meade is the brain. He's the guy with the slide rule. He's the one who has the idea of a better aircraft engine. And the two of these men leave Wright. And what they do is they're looking for a place to set up shop. You see, I mean, they don't want to build a factory. They want to use an existing factory. And they want to be able to build their aircraft engines with the machine tools that are already available in some factory someplace, you see. And the factory that they made the deal with was none other than Pratt and Whitney machine tool, you see. And their designs, Mr. Meade's design, leads to a successful aircraft engine of his design. And Pratt and Whitney is so busy building these aircraft engines that becomes their primary thing. They don't have to build sewing machines or whatever else they were producing. I mean, this is now the business. They are building aircraft engines. And the whole enterprise takes on the name of the original shop, which is Pratt and Whitney. Except now, instead of Pratt and Whitney machine shop, now it's Pratt and Whitney aircraft engines. And that's where the beginning of this is. It's in Hartford, Connecticut. Isn't it a great logo? So here's the building now in East Hartford. You know, this is just one building out of like a dozen buildings. They have all kinds of other administrative offices, etc. Now, the thing here is with Pratt and Whitney is they actually join up eventually with several other companies, and they wind up being part of a very, very large group of companies, right? And the government doesn't like that, right? In the 1930s, they considered it to be an antitrust violation because you didn't want to have a monopoly. So the fact that Boeing aircraft had hooked up with Pratt and Whitney aircraft, who had then hooked up with another manufacturer of propellers once again in Connecticut, which was Hartzell Propeller, if I'm not mistaken. The government thought that they had created this monopoly on aircraft travel and manufacture. And not only that, but they added to that their own airline called United Airlines, see, which you may have heard of. And so the government broke it up. So Pratt and Whitney just went back to being Pratt and Whitney, you see, and everybody became their independent companies again. Strangely enough, after the 1990s, they went back to being these big monopolies again, you see. So you have these massive corporations that have like 15 different sub corporations in them. United Technologies and now Pratt and Whitney is actually under the banner of Raytheon, which, if you know, is a manufacturer of radar systems primarily, but so many other things. When I was working on boats professionally as an electrician, I was a trained radar installer, and many of the radar systems that I installed were actually Raytheon units. So here we go. Now, you're going to be excited about airplane engines by the time I'm done with you today, or I'll eat my hat. All right. And if you like mechanical things, this is a work of art that you're looking at. This is the brainchild of Mr. Meade. This is something called a WASP Junior, right? Now, all of the engines the piston engines that Pratt and Whitney was to become famous for were all part of a series of engines called the WASP series. And this is a relatively simple design, right? This happens to be the R985, and it's called the WASP Junior because it was the smaller one out of many larger ones that were to come, right? So it required the name WASP Junior, right? And it's in a Boeing Stearman, which was a famous aircraft of the day. Now, I want to tell you something about this engine. You see all of the cooling fins on it, on the cylinders, right? How many cylinders? I think it's 9. 1, 2, 3, 4, 5, 6, 7. Yeah, 9-cylinder engine. And this is something called a radial design, okay? Because it's like a clock, right? And the cylinders are arranged around this center crankshaft. So it's called a radial engine, you see. And if you think about, if you still have an automotive engine, like a gasoline internal combustion engine, like I do, right? In my particular car, my Acura, I have an old Acura, and it has a 4-cylinder engine, which is called the 4-cylinder inline engine, right? I've got an old 2 vehicles that still have V8 engines. I've got a Chevy pickup truck, and I have an old Corvette. And both of them they're like 4-cylinder inline engines, but they're actually, the banks of the motor are like this, you see, at about 60 degrees opposing, right? So 2 banks of 4 connected in the middle makes a V8, you see. Now, engines like that were used in airplanes in World War I and World War II, except they had to be cooled by water the same way your car engine has to be cooled. So you had to have a radiator, and you had to pump water through it, you see. And those longer engines, you can see that when they fit into the fuselage or the nacelle of an aircraft, they tend to be more streamlined, more, more narrow, you see, because they're in line or they're a V design, you see. The aircraft engines that use radial design tend to be larger in the front and usually circular, right? And that's because of you have to accommodate all of those cylinders up front in the diameter of the thing. But the advantage of the radial engine is that it doesn't have to be water cooled. So you have no radiator, you have no cooling hoses, you have no internal water jackets, you see? And this is, in a military application, a tremendous advantage, because it's one less thing to break. And remember, if you're in a situation that these military aircraft were in, not that the Boeing Stearman was a military aircraft, right? You're getting shot at, right? The idea is to put a bunch of bullets into your engine and hopefully either kill the pilot or shoot up the mechanisms at the engine so that you lose oil pressure, you lose your gas line, the engine sputters and dies. And one more major disadvantage of a cooling engine, one that requires a radiator, is that if you shoot up the radiator, obviously all of the water drains out and the engine overheats. And then, then next thing you know, you're jumping out of the aircraft in the parachute, see? So an aircraft engine that doesn't require any kind of cooling by water eliminates an entire vulnerable system from going bad. And now, of course, the fact that you're traveling through the air at 100 miles an hour, 200 miles an hour, 300 miles an hour, 400 miles an hour, depending on the aircraft, you have all of that wind that's hitting the cylinders. And the reason why you have all of these little fins on there is to dissipate the heat that is inside each one of the cylinders, right? And so there's a major advantage. Now, I hope I just didn't bore you to tears with that, okay? But it's interesting stuff. Now, this puppy here, okay? This is a improved version of the Wasp Junior, right? So you had several different versions of the Wasp Junior that became larger, and they just simply became the Wasp. And then when you took essentially two Wasp engines and you put one right behind the other, then you double the number of cylinders and you wound up with like an 18-cylinder engine, 9 and 9. So it was big enough, but it was still small enough. And it became the ideal size. And it was called the double Wasp, right? Because it had 2 rows of cylinders. And here's a beautiful example of a restored double Wasp engine, right? Now, this is all the brainchild of Mr. Meade and all of the other geniuses that they had over there building engines at Pratt and Whitney now, designing and building engines. And this double Wasp engine is probably the most iconic engine of all time regarding classic aircraft, okay? I'm going to show you some photographs of aircraft that used the double Wasp engine. Here is the largest version of the Wasp series, right? And this is called the Wasp Major, right? So if you had the little engine, which was the Wasp Junior, and then you had the Wasp, and then you had the double Wasp. And now the biggest one, and this is the epitome of internal combustion radial engine design. This is as big as you can get. That was it, okay? So after this, you had technology post-World War II that could actually, you had different technology, turboprops, and different sorts of things. It wasn't practical at this point to make a larger piston engined aircraft, right? In the same way that you had the double Wasp, which was double row, this had 4 rows. and 28 cylinders, right? That's 28 pistons, 28 spark plugs, right? I mean, it's an incredibly complicated machine, and it's just a wonder that these things ran as well as they did, as dependably as they did. It's really incredible. If you like mechanical stuff like I do, I mean, you're in awe of something like this. Okay, so here's, I wanted to use some pictures of things and people that we would be familiar with, right? This, of course, is a beautiful picture of Amelia Earhart. And Amelia Earhart, I don't know if you know the story of Amelia Earhart. She was lost in this aircraft, by the way, in 1937 on a trip around as close as you could get to the circumference of the Earth at the equator, right? Because Amelia Earhart didn't want to be accused of taking the Wimp's Road of circling the Earth at a higher latitude, right? She wanted to circle the Earth at the widest part of the Earth, right? Because she didn't want anybody, she wanted to, for those women in my audience today, I mean, you may have heard the phrase that, a woman's got to do it twice as hard or twice as good to get half the credit, right? So Amelia Earhart didn't want to be seen as taking a shortcut. So this aircraft,
It's real bad feedback.
Okay, I don't know what that is.
I'm trying to get somebody muted. There, just muted her.
Okay.
Sorry.
Okay. Anyway, so Amelia Earhart was famous, of course. And so she was teaching, and Lockheed, the aircraft company, wanted to be associated with her. And they essentially gifted her this aircraft, which was the state-of-the-art aircraft in the 1930s, right? It's called the Lockheed Electra. And there are many Lockheed aircraft that flew in World War II that were based on similar designs to this. As you can see, it's a twin-engine aircraft. And this aircraft was especially built for Amelia Earhart. What they did was they took all of the passenger seats out, and they essentially turned it into like a big flying gas tank. And so because they knew that she wanted to travel long distances. And she and her navigator, what was his name? Fred Noonan, I think. They flew this aircraft around the world. She was lost in the middle of the Pacific Ocean. And the engines, of course, are Pratt and Whitney WASP 1340s, okay? And so here's a famous aircraft that is associated, and a famous person associated with the most dependable aircraft engines that you could get, according to Pratt and Whitney, and they certainly were. Yeah, so you can see the shape of the engine nacelle, right? The part that encloses the engine. And you can tell right away whether or not an aircraft is using a radial design or an inline design, because the shape of the engine nacelle would be completely different. All right, our story today is all going to be about these radial engines, because that is what, or at least from this era, that is. Because that is the type of engines that in the WASP series that Pratt and Whitney became famous for. I got a really good program on Amelia Earhart, by the way. Here's another famous aircraft from World War II that was very, very significant, using Pratt and Whitney engines, WASP 1830s. And it's called the B-24 Liberator. consolidated B-24 Liberator. And these were produced in larger numbers than any other military aircraft in World War II. An astounding number. The size of the airplane and its usefulness was the equivalent of like a Boeing B-17 Flying Fortress, right? When we talk about the air war over Germany, right, you had two different kinds of airplanes, primarily heavy bombers in the American Air Force that were flying over Germany, and the 8th Air Force primarily used B-17 Flying Fortresses of a design by Boeing, and those used Wright Cyclone engines, okay? But the famous B-24 Liberator flew from Italy over the Alps in the 15th Air Force and bombed Germany using these B-24 Liberators. And all of the Liberators were equipped with Pratt and Whitney radial engines. Henry Ford famously had a factory in Detroit, Michigan, right, where it was called the Willow Run Factory. And it was the largest single factory space on the entire Earth. And the reason why they built the plant was for no other purpose than churning out these B-24 Liberators. Right now, here's a picture of a B-24 Liberator over the Pacific in World War II. And it's over a famous island. And the name of the famous island, if you haven't already recognized it, I don't know where my World War II buffs are. This is Iwo Jima, which translates to Sulphur Island in Japanese. And it's Sulphur Island, and that is the famous Mount Suribachi that this Liberator is flying over. Mount Suribachi, if you don't know the significance of that, you know that famous Marine Corps picture where the guys are lifting the flag up, right? And that is on the top of Mount Suribachi. It's a beautiful picture of a Liberator. Pratt and Whitney, double row, 1830 Wasp engines. Awesome. Here's a great picture. This is a Rosie the Riveter picture, right? Because I wanted to give a hats off to Rosie the Riveter because it was women to a large degree that were manufacturing and installing these engines all across the United States, right? It's one thing to manufacture an engine, it's another thing to mount it to an airplane. These are very complex pieces of equipment. And there's this young lady on the left, typical Rosie, and that is a Wright Cyclone double wasp. I mean, I beg your pardon, a Pratt and Whitney double wasp engine right there. Then this is the most famous variant of this series. And this is going to go into, if you can see the jumpsuit of the guy in the foreground, right? It's from the Vought Aircraft Company. And you can see that it's hyphenated Vought Sikorsky, you see, because they were building the F-4U Corsairs, right, from Chance Vought. They were doing it in conjunction with Sikorsky Aircraft, right over here in Connecticut, down by, if you know where Lordship Boulevard is, off of, like by Stratford, right, off of 95 there. And so there's a manufactured engine from Pratt and Whitney, and it's being bolted up to an aircraft frame that's going to be a Chance Vought Corsair. Now I've got some nice photographs of them. Now here's the aircraft that changed the tide in the Pacific as far as the United States having an airplane that was better than the Japanese Zero, right? The Japanese started the Pacific War in, well, we were involved, of course, December 7th, 1941 and afterwards. And the Japanese had aircraft that were better than ours. They can outmaneuver our airplanes, they can outshoot them, they can outdive them. And Grumman came up with a design that could actually best the Japanese Zero. What happened was that the Japanese, we were fighting in the Aleutians, and there was some Zero that got landed there, and it kind of, I think it pitch poled and landed on its back or something. And the Japanese sort of left it there in this frozen tundra up which where the Aleutians are. And the Americans were all too glad to flip it back on its wheels and fix the thing and fly the hell out of it and figure out exactly what we needed to do to build an airplane to surpass its capabilities, you see. So, and that airplane was the Grumman Hellcat, right? All of the Grumman aircraft were named after cats, right? The aircraft before this was the Wildcat, then you had the Hellcat, and then immediately at the end of the war, they had another one called the Bearcat, right? And this aircraft uses that famous double wasp engine, Pratt and Whitney double wasp engine. And it is a famous design. It was faster, more maneuverable, can outclimb and outdive a Japanese Zero. And one of the things that made that possible was that Pratt and Whitney engine. And these flew, this became the primary aircraft that were flown off of carrier decks, aircraft carrier decks in the Pacific. And we were giving hundreds of these things also, the Hellcats, to the British, and they were flying them also. There's what a bunch of Hellcats looks like on the deck of an aircraft carrier. And I don't know if you've ever been on the deck of an aircraft carrier, let alone an aircraft carrier at sea with aircraft that are actually have their engines running. I've only been on an active aircraft carrier with engines running that were jet airplanes. And it is a very, very dangerous place. It's the most dangerous place in the world. You can certainly see why it is so dangerous. I mean, despite the fact that you have these spinning propellers and you have these fellows over here that are maneuvering the airplanes around while the engines are running, which I don't have to tell you will chop your arm off in a microsecond. If you're around a jet engine, the jet engine, you can be fried to a crisp by the exhaust of the jet engine, or you can get sucked into the intake of the jet engine. You can see also that naval aircraft like these Hellcats, they have folding wings. So Grumman designed them so that the wings could be folded and left folded to conserve space. An American aircraft carrier, World War II vintage, could go to sea with 100 airplanes on it, right? Which was extraordinary. Even a British aircraft carrier, a contemporary ship to an American aircraft carrier, only went to sea with like 43 airplanes, you see, for a number of reasons. So when you were ready to take off, the wings would unfold and lock into place. But anyway, there's the Pratt and Whitney Wasp 2800 double Wasp in action. There's a Corsair. You see, these are Corsairs on the flight deck of probably the USS Midway. And Corsair was an airplane, like I said, it was very unique. It had gull wings on it, and it had a four-bladed propeller, and it would use that Wasp 2800 double Wasp engine. That picture I showed you of the Rosie the Riveter a couple of slides ago, they were bolting a Wasp 2800 to the firewall that's underneath the cowling of these Corsairs. These Corsairs, actually, we used them in the last 2 years of World War II, and we also flew them straight through Korea. There's a beautiful photograph of an F-4U Corsair. It's one of the most iconic historic aircraft that exists. Essentially a Connecticut product. Not only the aircraft, but the engine too. Awesome, right? And there is a close-up of the engine nacelle of a Corsair, right? That's what it looks like. And so here you can see clearly that WASP 2800 double WASP right behind the propeller there. And by the way, these propellers were manufactured in Connecticut also. So the aircraft was manufactured in Connecticut, the engine, as well as the propellers. And these propellers are a real, they're a technological marvel, just the propellers themselves. This is no simple thing, making a propeller. I can do a whole program on that. Luckily for you, I'm not going to. And this device that is in the hub has a whole mechanism inside that makes it possible for the pilot, by the simple turning of a lever or pulling of a lever, can actually change the amount of bite that the propeller has. In other words, the relative angle of bite. So all three propellers will actually turn, you see, and the different attack attitude towards the wind or cutting the air will change. It's called a variable pitch propeller. And it is an incredible technological achievement in the performance of an aircraft that was achieved, before World War II and perfected during World War II. In Connecticut, it's a great example of how Connecticut was known for its, the high-tech innovations and manufacture and precision machinery. And this is a piece of precision machinery, every bit of it. Another iconic aircraft using the WASP, the double WASP 2800. This one over here. All right. This is a P-47 Thunderbolt. All right. It's an Army aircraft, Army Air Corps. So P stood for pursuit. It's a pursuit aircraft, right? After the Air Force became its own service in 1947, the designations were changed, and whatever was a pursuit airplane became a fighter airplane. See, so they went from P as a designator to F as a designator, right? Now, this is an early version of a P-47. These were flown primarily over Europe, all right? And this aircraft here is an earlier model. So it's referred to as a Razorback. Razorback refers to the fact that the canopy where the pilot sits underneath it, the pilot is underneath the canopy, the plexiglass canopy. It is like a fastback, you see. The later models, they did away with the fastback, and they had like a bubble enclosure because it gave the pilot 360-degree view, and that's how you can designate an earlier model from a later model. And so that's the same engine that's being used in the Grumman Hellcat, the Corsair, right? Now this aircraft over here, you'll notice that if you know your World War II history, has something called invasion stripes on it. And see the big black and white stripes on the wings and on the fuselage? That was for the invasion of Normandy in 1944 to designate quickly, when you look up, that it was an American or an Allied aircraft, right? An American or a British airplane. Well, then they just painted all of these big black and white stripes on them. As it turns out, the German Air Force was, almost, to use a word, kaput by that point, but they weren't completely kaput. But you needed to know who to shoot at, so that's what the invasion stripes were for, right? And This airplane was very large and it was very heavy. And its nickname was the Jug, right? You know, everything had a nickname. Everything and everybody had a nickname. It's called the Jug. A very large, heavy aircraft. But you didn't want to be on the wrong end of this thing because it had these massive cannons that you can see in the wing here. Now, this airplane was primarily used for running down Germans on the ground while we were chasing them from Normandy all the way back to the Rhine barrier, you know, in other words, across France, across Holland, Luxembourg, etc. And so as the Germans were retreating, and I don't want to call it a rout because it wasn't a rout, you know, but nowhere the Germans could have a convoy and not be harassed by these P-47s. These P-47s would dive on troop convoys and equipment convoys and supply trains, and they would just blow them the hell up. You just strafe them and load them full of lead and rockets. It was devastating for the Germans. By the way, just as a point of interest, you see the what typically would be called nose art, but since it's already got this checkered theme on the nacelle, you see in the center of the aircraft, it's the famous World War II designation of military slang called snafu. Right now, the snafu is part of regular, like, American lexicon anyway, but it's an acronym for something. Some of you are going to know what this is. I don't want to ruin it. Okay, so SNAFU, right? So a snafu stands for, in Army terms, situation normal, all effed up. You got that? Snafu. Situation normal, all effed up. Here's another aircraft that was used extensively as a bomber in World War II, particularly once again in Europe, but not exclusively. And this is the B-26 Marauder, right? Martin, made by the Martin Aircraft Company. And it used, once again, like the last series of airplanes I showed you, the Pratt and Whitney double wasp, R-2800 double wasp, right? And this airplane was called a medium bomber. It wasn't as big as the B-17s or the B-24s. But we use these things extensively. Is a bomber, Pratt and Whitney aircraft. Now, immediately after World War II, we were in a new phase of, well, what can we call it? Technology, because you had nuclear weapons, you see, right? Nuclear weapons. So the idea was that the war was going to be obsolete because the specter of having a nuclear conflict was unthinkable, right? Because what's the point? Because everyone's obviously going to be dead, right? Which kind of makes sense. That's where you got the acronym MAD, which stands for mutually assured destruction, right? Now, as it turns out, the Soviet Union, because they had such extensive spies in our atomic bomb program, the Manhattan Project, the Soviets achieved their own nuclear weapon as soon as 1949, which was like 10 years before we thought they would be able to do it, right? So now you've got a nuclear armed Russia. So we've got to up the game, and we have to create a deterrent from Russia doing anything stupid, and particularly in Western Europe, right? Because Stalin was already, you had countries by 1947 that had fallen behind something affectionately referred to by Churchill as the Iron Curtain. So we needed to have a show of force, and we needed to show that we were prepared not only to attack our enemies, which was Russia, by the way, but protect ourselves. Protect ourselves by having a good defense, you see. And so you had these things that were called strategic deterrence, right? So we had submarines at sea that could launch missiles, and they were there. They were called deterrent patrols. And the idea was that what is the point of Russia launching an attack on the United States if a bunch of submarines were going to retaliate overwhelmingly to Russia? You're only going to get killed yourself. So what's the point of attacking the United States? You see, that's why they were called deterrence patrols, right? And these are also strategic deterrence flights, right? Flown by the Strategic Air Command. So now you needed an airplane that could greatly exceed the range and the altitude and stay of World War II aircraft and stay airborne for an extended period of time, you see, because you're flying truly now, you know, over continents, over oceans, you know, you're literally loitering in the air on a regular basis with nuclear weapons in the bomb bay, you see. The Strategic Air Command. And the aircraft that was the first major intercontinental bomber was something called the B-36 Peacekeeper, which is shown here. And yeah, I mean, it's just an enormous aircraft. And you can see that it's still using propellers, right? So it's got 3 aircraft engines that are pointed backwards. So this is actually what's referred to as a pusher aircraft, because instead of pulling the aircraft forward, you're pushing it, you see. 6 engines. And the later models of the Peacekeeper actually had jet engines outboard to aid in thrust in taking off, because this is an enormous machine, as you might imagine. Right, and this aircraft here used that WASP major engine I showed you the photograph of earlier, right? This is the epitome of the WASP series of the engines, the radial engine design that had, what was it, 28 cylinders, I said? And it's just amazing. The power plant in these things, ×6, you see? So this is the B-36 Peacekeeper, Convair, right, which was another famous airplane company. Here is another famous aircraft that you may recognize. This is now an aircraft that was designed in the late 1960s and put into service in the 1970s, and it is the famous F-14 Tomcat, right? So if you've ever seen the original Top Gun, right? The aircraft that was used in those films was, or at least Tom Cruise's aircraft, was the F-14 Tomcat. It's a very bad looking aircraft, right? And I mean bad in the kind of like, you know, cool sense, right? I had a very bittersweet experience when the Tomcat program was finally canceled after the Persian Gulf War in 1991. I was, you know, already in the management at the Intrepid Sea-Air-Space Museum in Manhattan, and was in charge of the entire aircraft collection there. And I was their head curator in such matters. And Grumman Aircraft out in Calverton, Long Island, was where these things were manufactured, right? And they were closing shop after all these years, right? You had before World War II, you had all of those aircraft during World War II, you had all of the aircraft that were built during the Korean War and the Vietnam War and everything else like that. And now they are shutting down the factory. Very sad stuff. very sad, like people, like somebody in the family died, you know. And I got sent out to Calverton to choose one of two F-14 Tomcats that they had used internally for their own research, testing, and development. Okay. So because I was part of the largest museum in the Northeast of such matters and the largest naval museum in the world at that point, I got to choose which one I want. So I picked the one I wanted. And then it was my responsibility to get that airplane all the way back to Manhattan, all right, which is another story I'll tell you someday, okay? And very cool stuff, even though, but it was very bittersweet at Grumman headquarters in Calverton. So this aircraft here is using now, obviously, jet engines, and these jet engines in this Tomcat are manufactured by Pratt and Whitney. There's a couple of F-14s, right? F-14s had a, it was variable wing design, by the way. So that means that there was a computer on board that actually would change the, it would change the angle of the wing, you see. You know, when you're flying slower, like when you're taking off or landing, you need more of a straight wing, you see, for a certain kind of lift. But if you're going to go, if you're going to, you know, break the sound barrier and exceed the speed of sound, which these aircraft, of course, were capable of doing, you need a wing that is more of a delta shape or at a certain angle, you see, or else you won't be able to break the sound barrier. And so the aircraft actually, depending on how fast it was going, was coupled to the computer on board, which would automatically regulate the setback of the wing. It was a remarkably innovative design. Now here's another aircraft that's still in service in air forces around the world that the United States sends, you know, military hardware to, and it's many, all of our allies. And we fly these things too. We still have them. This is the Army's, or rather the Air Force's Boeing F-15 Eagle aircraft, a phenomenal aircraft, right? A phenomenal aircraft. It is not the latest generation of aircraft, but it is a phenomenal aircraft. And this also is powered by Pratt and Whitney turbofan engines. Here's another aircraft that is famous, and it is the McDonnell Douglas F-16. They call it the Fighting Falcon, okay? And it is a single-engined aircraft using Pratt and Whitney turbofan jet engines. And it is remarkably maneuverable. This is the first aircraft that had what was called fly-by-wire, which means that instead of having hydraulically assisted controls, it would literally, everything would be electric, right? So that means that if you pull the stick back, a rheostat would determine electrically how much the aircraft elevator would have to actually be turned by motors, you see. So it was completely fly-by-wire. A lot of composite materials in these aircraft. And I went to Syracuse, New York, for a ceremony where the Army National Guard gifted the Intrepid Museum one F-16 Fighting Falcon that had flown in the Persian Gulf War, and I was the official recipient to it. So you know, rhetorically speaking, they actually, or symbolically speaking, they handed me the registration and the keys, right? And then, of course, it was my responsibility to get it from there down to Manhattan. right? In parts, by the way. The airplane had to be disassembled and it had to be flatbedded. And then when it got to Manhattan, I put the airplane back together. Okay, that's what I used to do. And awesome airplane. They were called the Boys from Syracuse, by the way. And Pratt and Whitney aircraft engines. These planes are in service all over the place. The Israelis use them a lot. Here's another iconic aircraft using Pratt and Whitney turbofan engines. The redoubtable, right? Boeing B-52 Stratofortress, right? The Boeing B-52s have been in service literally since the 1950s. There are people who are flying B-52s now because they're still in service. We just buzzed Iran with one of these things like 2 days ago, right? And you got a B-52 flying over your head. It means that this is called gunboat diplomacy, to borrow a term from the 19th century, right? And what gunboat diplomacy means is that we could kick your ass anytime we want to, just letting you know, right? That's what it is. And it doesn't matter if it's 2022, it doesn't matter if we have the most sophisticated cell phones in the world. Some things never change. And no matter who it is, everybody knows what comes out of the barrel of a gun. Very simple stuff. So there are people who are flying B-52s now whose grandfather were flying B-52s, right, back in Nam. It's amazing. I mean, it's a testament to the design and the durability of this aircraft frame. B-52 Stratofortress, okay? Isn't that awesome? And this is from, by the way, this is from a KC-135, I think it is, tanker, which is another Boeing aircraft, which, by the way, also uses Pratt and Whitney airplane engines, okay? And the idea, what's happening now is this is the view from somebody who's about to refuel a B-52. So directly in between the wings there, on the top of the fuselage, is a receptacle where this aircraft that the photograph is being taken from is about to lower this long boom. And that boom is going to engage with the, with the nozzle receptacle. And then they're going to turn the valves on. And, you know, who knows how many thousands of gallons of JP5 jet fuel is going to rush into the tanks on that B-52. Then they'll disengage and she'll be ready to continue her mission, right? And I hope you'll forgive me for using the traditional gender terminology of these things. I don't mean to offend anybody, right? But I'm not ready to refer to ships and airplanes as they, them. So the aircraft that's behind this B-52 is waiting in line to refuel once this aircraft is been refueling. And the baddest boy of all, the fastest aircraft that has ever flown in the history of the world, and probably ever will. This is the Lockheed SR-71 spy plane, right? Powered by Pratt and Whitney J58 axial flow, right, engines. Unbelievable. This airplane can top 3 times the speed of sound. Over 3 times the speed of sound. That's like Mach 3.5. It's beyond comprehension. right? Now, this was built by a guy named Kelly Johnson, and Lockheed Aviation had this special bunch of geeks in the back office, and they called it the Skunk Works, right? And the Skunk Works was responsible for all of the stuff that nobody was supposed to know about. And they made airplanes that were the first stealth aircraft. So here is essentially the first stealth aircraft. This one over here was made with composite materials, and it had certain design features in it that were designed to break up the radar signal of anyone who was trying to find the airplane with radar. And it also had a special black finish on it. And the black finish was made up of a special chemical compound that actually absorbed radar. You see, the whole point of radar, of course, is to bounce a radio signal off of something metallic, and then have a strong return echo, is what it's called. See, but if you can hit something that is going to actually absorb part of that signal, you're not going to get as sharp of a radar return, which is the point of the special coating. We used to fly over the Soviet Union with something called a U-2 spy plane. You see, you've probably heard of them. Gary Powers got shot down. Remember all that? And it's before I was born, but the Soviets were pretty angry at us because it's like invading a country when you're flying over their airspace without their permission. Say, they have the right to shoot you down. It's an act of war. So we had to kind of like grovel and eat crow for a while because we got caught flying over Russia, being we were looking for their missile silos, right? Back in the 1950s. And then Eisenhower promised them we would never do it again, right? Which was, essentially bullshit. What we did here, then Kelly Johnson and the Skunk Work, they came up with this thing, right? And this is the second version of the first version was an A-12 Blackbird, right? And then the second one was the SR-71, which was a slightly improved version. And it has no other purpose than to spy. It just takes pictures, you see? But this thing here was going to be so fast and could fly so high that we were going to fly right over the Soviet Union, and there wouldn't be a damn thing they could do about it. Their missiles couldn't catch it. Their airplanes couldn't catch it. By the time they spotted it on radar, the thing was already gone. See? And that's what this was for. Now, this got retired in 1991-ish. And it's a very expensive program to maintain. The airplane had to be rebuilt after practically every time they used it. It was so stressful on the airframe. And then now that you have satellites that can do a lot of what these things used to do, it doesn't really pay to have a program like this. It just costs too much. But for airplane buffs everywhere, it's still like the most kick-ass, awesome aircraft that ever existed. Just take a look at this thing. And remember, this thing was something that was designed in the late 1950s. Okay. I was in charge of the only one in the entire Northeast. We still on the deck of the Intrepid. I was heavily involved in restoring it. Amazing airplane. Commercial airplanes, right? That was something that completely after World War II, World War II actually pumped a lot of life into the train industry. The trains were going to be a thing of the past in a very short amount of time. Within 20 years, between 1945 and 1965, every major train company was on the verge of bankruptcy. You may remember this from our own region. Well, actually, I lived in New York at the time, and I remember when Pennsylvania Railroad became Penn Central, right? Because the New York Central was going bankrupt and the Pennsylvania Railroad was going bankrupt, so they had to merge and became the Penn Central, right? Et cetera, et cetera, et cetera. It happened all the way across the country. And the thing is that once you had practical aviation, that you can, I don't know, go to LaGuardia Airport, Bradley Airport, wherever it is, and get on a 707 and be in Florida in 2.5 hours, reliably, comfortably. Back in the day where, aircraft companies were actually catering to the customer, and competing for your business. I mean, not only that, but we were in such a period of kind of like social, I don't know, I don't want to call it progress, but we were in a period of time where young people who had lived through the Great Depression and then fought World War II, maybe Korea, I mean, in the 1960s, taking a train to Chicago, well, that was like something your grandparents would do, right? So it was it had this kind of like 19th century element to it, and got on an airplane. This happens to be one of the most successful designs of all time, still flying today, the Boeing 707, powered by Pratt and Whitney turbofan engines, okay? And if that wasn't enough, I remember the first time I saw one of these things, John F. Kennedy Airport, the Boeing 747, right? Introduced in, I think it was 1969, if I'm not mistaken. I mean, a jumbo jet aircraft, right? I mean, it's just unbelievable, right? Beautiful aircraft, very, very successful. And this also was powered by Pratt and Whitney aircraft, jet engines, right? Which is obviously the theme today. I'm not going to show you pictures of anything that isn't using Pratt and Whitney aircraft engines, okay? But I just wanted to, I mean, the point here today, there's only so much I could tell you about. It's not a program on aircraft engines, technically, so I wanted to show you the social impact that Pratt and Whitney had on, the world, essentially, by its importance of its leading edge technology in the aircraft engine industry. And this is today, right? So you have the big conglomerate Airbus, which is, a European Union kind of a thing. It was, put together 30 years ago to compete with Boeing. I mean, I remember when I was a kid, I mean, if you wanted to get on an aircraft, if it wasn't an American company, that what was it? It was either Douglas or it was McDonnell Douglas when they merged, or it was Boeing, But then you had Airbus, and Airbus became a competitor for the first time. I guess it was the 1980s probably, when Airbus really started showing up in mass, and large aircraft companies started buying Airbus aircraft, you see. So Boeing had a competitor. So the A320 series, their wide body aircraft, are powered by Pratt and Whitney aircraft. You see the logo on the side of the engine nacelle? And this is a pretty big deal. The competitors to Pratt and Whitney in this market are primarily Rolls-Royce. Rolls-Royce and General Electric are the only two big other companies that manufacture these kind of power plants for these type of engine aircraft. And for the military market too, by the way. See, that's the same airplane, right? So this is present day. This is current time, real time. And so there's the Airbus A320. And as you can see on the side of the engine nacelle, they're proudly sporting the original Pratt and Whitney dependable engines, right? Signifying that it's a Pratt and Whitney power plant in there, which is bragging rights. So why is there a ship here? Well, because modern ships use gas turbines, right? Now, this is a ship that happens to be a Coast Guard cutter from the vintage 1970s, 1980s, 1990s. By now, we've actually sold these to, we've sold them to Well, I think we sold it to Vietnam, as a matter of fact, and they're primary Navy ships for them. Okay, but modern ships use gas turbine power, right? So imagine a jet engine, right, that is mounted on a frame, right? And what they do is they run the jet engine, and you send the center shaft of the engine through a bunch of reduction gears, and then that gets used like a transmission to the propellers. You see, it's gas turbine propulsion, you see. And this ship over here, the United States Coast Guard cutter Hamilton and her sisters all use Pratt and Whitney gas turbines to run their power plants, right? So there's no, I mean, they had diesel engines as a secondary source, you see, but there was no steam engines or anything else like that. The primary propulsion is gas turbine. Okay. Now, our modern warships that we have today, that like Arleigh Burke class destroyers, etc., they use gas turbines too. The reason I didn't put them in this presentation is because they're using General Electric gas turbines, but it's the exact same principle. You see, General Electric is a competitor to Pratt and Whitney in this market. You know, all of our modern, well, at least the smaller ships, right? The destroyers, the cruisers are all gas turbine. Well, it's not really an airplane, is it? This, of course, you'll recognize as the famous space shuttle. You all remember the space shuttle, right? It's the first platform that the United States had where you could actually reuse the thing, you know? So the main fuel tank would drop away, the booster rockets would drop away once the main aircraft body was in space, the spacecraft. And then it's shaped kind of like an airplane because it would come through the atmosphere on the way back, and it would actually land like a big airplane, you know. It was kind of like putting wings on a brick, but nevertheless, it was able to land, right? And so you can see that the propulsion, when the thing is to defeat the Earth's gravity to get this thing into orbit, they use the boosters, right, on the side. But once the thing is actually in space, the way it gets around is with its main engines, which you can see in those three, what they're called bells on the back of the aircraft, right? And those engines, those three engines, the main engines from the space shuttle, are Pratt and Whitney engines. That's what one of them looks like, you see? So there's three of these on the back of the space shuttle, right? And it's another company called Rocketdyne, which in conjunction with, which is actually a company that was run by Pratt and Whitney, okay? Aerojet Rocketdyne, right? Pratt and Whitney. And so you can see here, literally, here's a Pratt and Whitney aircraft engine that is a rocket engine. And there are three of these mounted on what are called gimbals. What a gimbal is means that the three engines can actually turn in unison, right? Imagine like when you turn the steering wheel in your car, the two wheels turn together parallel to each other, right? And the point to this is that the computer will make course adjustments, etc., in space by actually pointing the bell of the thrust nozzle, right? The nozzle, or called the bell, in a certain direction. And this is referred to when you're actually changing the direction of the thrust, right? It's called vectored thrust, right? And that, I'm sure you always wanted to know that, but once again, here is a Pratt and Whitney aircraft engine. Pretty cool, right? And here is something that is ubiquitous in all of our armed forces today. Army, Navy, Marine Corps, Coast Guard, and in all of our allied inventories around the world is the ubiquitous Sikorsky UH-60 helicopter. You see? And this is like the Bell Huey from the 1960s in Vietnam, except this is a Sikorsky model. And this is the workhorse helicopter in everybody's armed service, right? And they are powered with Pratt and Whitney turbines. This is a bad boy. Now, I don't know if you recognize your helicopters, right? Of course, I labeled it anyway. This is called an Apache, right? Frankly, I mean, technically speaking, this is an Apache gunship, right? Now, if you see an Apache gunship, you're a dead man, is what you are. An Apache gunship is a helicopter that has the hitting power that is just extraordinary. You could destroy tanks. You could destroy a convoy of vehicles. You could destroy armored troop carriers. I mean, an Apache attack helicopter is the baddest weapon anybody ever saw, all right? And it is just one of the marvels of American military technology, and from a destructive standpoint, okay? And of course, it is powered by a Pratt and Whitney engine. And our latest models of aircraft in our military inventory, there are two aircraft specifically that I want to mention. Both of them are the latest models that we have. It's our frontline aircraft. We've sold them to all of our allies, right? And this is the F-22 Raptor, okay? It's our basic military fighter jet, right? It's a stealth aircraft. It's phenomenally maneuverable. It's incredibly fast. And it uses Pratt and Whitney engines. Shown here, by the way, an afterburner, right? So when you have the exhaust thrust that you then add extra fuel to, you can actually get an extra boost of thrust, right? And it's called afterburner, right? And you can see how the exhaust is lit up there. So she's an afterburner. Lockheed Martin F-35 fighter, right? Now you had an aircraft in World War II, a famous aircraft called the Lockheed P-38 Lightning, right? And that used an inline V-series Allison engine. You see, so that's why I didn't include it in today's program. It wasn't powered by Pratt and Whitney aircraft engines. But this aircraft is named after the famous P-38 Lightning. It's the Lightning II. And this is supposed to be the most sophisticated aircraft that is in anybody's inventory, you see, or at least in our inventory. And we're flying them. We gave them to the British and anybody else that we trust with our big secret, you know. And this aircraft over here, I don't know if you've ever seen an aircraft called a Harrier jump jet, right? A Harrier jump jet is something that the British came up with from Hawker Siddeley Company, and they used them in the Falklands War, etc. And you can actually, that aircraft has something called vectored thrust, which means that you can actually take off straight up and then change the direction of the thrust nozzles and then use it as a regular fighter jet, right? That was a Harrier jump jet. The F-35 is a vectored thrust aircraft. And like the Harrier, you can take off straight off vertically with it, or it could be used as a conventional aircraft, you see, and it has incredible maneuverability because you can actually change that vectored thrust depending on what you need to do. And it's, you could do things that a regular aircraft can't do. This is our most stealthy aircraft that we have. That's not a bomber, so the enemy can't see you coming, supposedly. And it, of course, is powered by Pratt and Whitney aircraft engines. See, there's an F-35 in a vertical ascent, right? So the single exhaust, right, where the thrust is coming out in the afterburner right now. You can even see the flames coming out of that, out of the wastegate. That entire assembly in the back is on a gimbal that can actually change from being straight back to down, you see. So you can actually, the aircraft can be forced up, down, sideways. It's pretty remarkable. Pratt and Whitney aircraft engine. Here is an example in the Royal Navy of an F-35. And there's a bunch of people standing on the deck of an aircraft carrier, a British aircraft carrier, by the way, called the HMS Queen Elizabeth, a ship that actually I was on. And here is the F-35. You can see, I don't know if you can see the wastegate that is pointed straight down in this photograph. But as you can see, the thing is landing straight down like a Harrier jump jet would have. It's, the advantages of something like this are obvious. Really awesome, right? Excuse me. I just wanted to show you a close-up. This is the front of an F-35, and it's kind of like on the SR-71 Blackbird. This was figured out 40, 50 years ago, that if you actually take things and you make them irregular shapes, when the aircraft get hit with radar beams, radar waves, if you have things that are shaped like a zigzag, it breaks up the radar beam. You see, so on all of these stealth aircraft, you include all of this technology where that is designed to break up the radar waves of somebody who's looking for you with radar, you see, and that's why it's like that. And you see this person in the cockpit, that might even be a female pilot, and it's just awesome, right? It really is. The kind of guts, competence, bravery, study that you have to have to be in a cockpit like this in whatever era. My hat's off to them. All powered by Pratt and Whitney. So you can see, I wanted to give you a range of some of the things that Pratt and Whitney was involved with. One thing I didn't mention was that also you have power plants that can actually generate electricity in the same way that those shift-borne power plants can. So you've got some big building with a stand, and you got a giant gas turbine on it, manufactured by Pratt and Whitney. And in the same way that you would mechanically drive a ship's propeller, they take the shaft of the turbojet engine and they actually put it through reduction gears to do mechanical work. And the mechanical work in this case for a power plant would be to drive a big generator. You see, so you have these very large installations of Pratt and Whitney gas turbines that are actually power plants. Anyway, so in the time that we have, in an hour and a half, I wanted to make it as interesting as I could for you and to highlight Pratt and Whitney aviation. I hope you enjoyed today's presentation. It's my pleasure, of course. Thank you.
Thank you. And Art, we had a couple comments. One of them that came earlier was, it must have been early in the program about no coolant that you were using, that the engines were using, and how it made sense for, I think it was during the World War II aircraft area. So that was one comment. And I think you answered this, but I just wanted to be sure what plane was used in the movie The Top Gun.
Okay, so the last thing you said was about Top Gun.
Yes.
So our Top Gun airplane is right here. F-14 Tomcat.
That's the one.
F-14. I mean, it's awesome. I mean, if you've ever stood next to an F-14, I mean, it's just, I don't know. You know, after the movie Top Gun came out with Tom Cruise, which featured the Tomcat, the Navy recruitment for people wanting to become fighter pilots just went through the roof. You know, I mean, it's just, yeah, you know, it's just, was just incredible. I mean, and, you know, it's the chance that I had to have a sort of an intimate relationship with the restoration of a major aircraft like this one it's been a privilege. I had a very interesting career in that regard. And as far as the air cooling is concerned, like for instance, you know, here's the P-47 Thunderbolt and some of these other aircraft engines, you know, I mean, if you have, imagine your car out in the driveway, okay? And you have like a regular gasoline car, it's not a Tesla, okay? And I came over to your car and I wanted to immobilize you. And I took, I don't know, I took a gun and I shot a hole in the radiator, right? You're done, you're finished. The water leaks out the radiator. Without the water, the entire engine will overheat and melt. You're finished. One bullet. You see what I mean? So the aircraft that used water-cooled engines, right? I mean, they had other advantages, but you also added a major liability, right? Because remember, people are shooting at you, you see? And all you need is a bullet or two to go through the radiator or one of the cooling lines, and you're done. You see, so the aircraft engines that were air cooled primarily and solely, like the R-2800, they eliminated an entire vulnerability in combat, you see? And by the genius of the designers, they were able to make the materials. You see all the fins on the engine? I mean, every part of the engine was a fin, you see? I mean, so therefore, literally what you're doing here is you're using thermodynamics to transfer energy from the hot engine cylinder into the ambient air. You see what I mean? One of the reasons why water is used in a water-cooled engine is because there's no more efficient way to transfer thermal energy from one thing to another by running water past it. You see, I mean, it's kind of like if you jumped into it's like the people on the Titanic, right? Who wound up in the North Atlantic. I mean, they wound up with hypothermia in a matter of minutes because water is a remarkably efficient way to suck heat from something, you see? You know, it's the second law of thermodynamics. And I'm not going to kill you with that, but take my word for it. All right. But as far as materials for airplanes, aluminum, aircraft alloy aluminum has two advantages. Number one, it's lighter than steel. And number two, there is no more efficient thermal conductor of heat to cool or cool to heat than aluminum, you see? So aluminum will radiate heat out faster than any other material as far as metal is concerned, you see? And yeah, it's awesome stuff. If you ever want to, and I'm afraid that I'll just bore my audience to tears. I love to talk about the technical aspects of this, but what I want to do is take something technical and make it interesting for you without drowning you in it, you know? So that's kind of like the fence that I walk on top of. And I hope that I've achieved that here today.
You have. And the last comment was about some of your previous recordings that we had done. Don't know who Kathy is. I will see if I can figure that out. Any of Arthur's previous lectures are found on the Edith Wheeler Memorial Library YouTube page. So you can just go there and view them all, not only this season, but previous seasons. So they're there. So that's easy to do. If you do want that link, please email me and I can send that out to you so that you can easily locate the YouTube page. If no other questions or comments, Arthur, thank you again for a wonderfully interesting and provocative and really cool lecture series. And we'll see you next week at 2 o'clock.
Very
Thank
good.
you,
Thank
everyone.
you.